Alright guys, let's try one all the way out. I'll show you all the steps. And normally in a test I'll actually ask you each kind of step, find the asymptotes, find the intercepts, blah, blah, blah. Okay, I'm not going to just graph this, do everything we did. Okay, be a little evil. So here, a good first step would be find the intercepts. So the y-intercept is a good place to start. It's the easiest thing to do up here. How do you find the y-intercept? Always? Make x 0. Do that magic trick there. 2. So y-intercept is 0, 2. How do you find the x-intercepts? Factor what? The top. The bottom would lead to where it's undefined, which would lead to vertical asymptotes. The only way a fraction can equal 0. And the x-intercepts would be those locations where you make the function 0 is if the top is 0. And what x value makes the top 0?
2.
Yeah. Because if you factor the top, you get that. I might as well go ahead and factor the bottom. We're going to need that on the next step. How do you factor the bottom? Bigger one's got to be positive.
Positive 2 minus
X plus 2x minus 1.
All right, cool. So now I can ask you, what are my vertical asymptotes? So we have letters in those words, so it will be a VA from now on.
X equals negative 2, x
Yeah,
equals 1.
x equals negative 2. X equals 1, cool.
Horizontal is 0.
horizontal.
Everybody's so good so far, or the reverse of that? Horizontal asymptotes. Look at the original. What situation am I in?
2x over x squared.
The bottom degree is
Bigger.
bigger than the top, right? So the bottom gets bigger quicker, the whole thing gets small. So the horizontal asymptote will be
0.
y equals
Y
0.
equals 0.
Cool. It's also got to be an equation of a line. At some point I got to be a real math teacher and get overly picky. This is actually not overly picky yet. All right, so we got intercepts, we got asymptotes, everything looks pretty good. We can start to lay the framework down, right? Put up our walls. It does sound like we're building a house. Because we're going to put doors in here too, yes. Yeah, because the vertical asymptotes are true walls. They're the ones that come from the domain. They're the ones that say, you can't go here. X cannot be this. So where do we get excluded values for inputs? The domain. Where's the domain come from? The bottom. Bottom can't be 0. Cool. So I've got... at negative 2 and 1. I've got a horizontal asymptote at y equals 0, which is also known as the
x-axis.
the x-axis. I like it. Okay. So it's naturally kind of broken up into 3 regions already. What else can I put up here? I got my y-intercept is 0, 2. My x-intercept is 2, 0. Now notice, now the vertical asymptotes are walls. You cannot go there. Horizontal asymptotes are suggestions. They say when x gets really big, you need to start getting close to me. Because look, right there, I am through the wall, right? So it's not really a wall there. This is a suggestion. When x gets really big, you better start getting close to me. In fact, I could have something where I have a horizontal asymptote and my function goes through it an infinite number of times. As long as it's getting closer and closer to it, yeah.
So
Exactly.
So that's why it's not a true asymptote, but it approaches.
No, it is an asymptote. It's just not a wall. It's not like you can't touch me. You have to approach me, slam up against me. That's starting to sound kind of
So
weird.
then, the definition of an asymptote isn't that it approaches it but never reaches it.
That is an asymptote.
That is an asymptote, but that's not the definition.
So here, this is the type of asymptote. Now I see what you're talking about. This is the type of asymptote where it's not that it never touches it, it's just that it gets closer and closer to it. The most classical example of an asymptote that we're most used to is one that gets really close and never gets there. Right? That's what we consider as a primary initial definition of asymptote. So now we've broadened our idea of an asymptote. It's something that has to get there arbitrarily close to it at some point past some point of x. You know, x gets so big that it never gets further away from it than something. It's got to get closer and closer to it.
And is it always the case that vertical asymptotes, like what you said, are walls? It's never the case that the line never reaches it.
Exactly.
Okay.
So with horizontal asymptotes where it's going through it repeatedly, will it just get infinitely closer but never just be the line? Because you
Yes.
said it's going to get closer and closer, but it'll never just be straight.
Exactly.
It'll always
be doing that.
going up and
Yeah.
down.
It depends on the function, but most functions that do that will forever be what's called periodic, like that. Forever be oscillating. That's what set up the oscillation in the first place. So, in theory, when you pluck a guitar string, it's supposed to, for infinitely long after that, it will forever be oscillating. In reality, it doesn't do that. At some point, it stops. Right? Okay, I went a little further than I wanted to. What about this section here? So we got three sections. We got here, here, here. What do I know, like here, for example? Where could it be? In this first region here, where could it be? Yeah, it could either be here or there. So how do I check to see which one it is? Plug in -3 and see where it is. If -3 output is here, then it's up there. -3 output's down there, then it's down there. Now in calculus, you're going to get a bit more specific about a few of these things. But for right now, this is plenty for what we want to do. So what do we get when we plug in a -3? What do we get? We get twice -5 over -1 times -4. So we get -5 and -2.5. Does that sound about right? Yeah, sounds about right. So -2.5. So at -3, I'm at -2.5. I'm right there. So that means I must be something like that. How are we doing so far? Do you guys see the plan of attack here? This is why I wanted to say it like this. You put the structure up, you put your doors in, and then you see where is it you still don't really know what's going on.
Wouldn't that be -1.5?
No. There's a 5 here, right? Sorry.
What's it, 5? Okay.
Yeah, sorry. -3 minus 2 negative. Yeah.
Okay.
Cool. I like the look you were giving me. That was pretty. And here, what's it probably doing in here? Can it go through the x-axis?
No,
Why not? How do you know that?
because asymptote.
There's no x-intercepts in there. Not because there's an asymptote, but because there's no x-intercepts there. Cool? And it's not allowed to just suddenly stop here and pick up there. It can't jump like that. This is continuous in each region. For sure, because this is just polynomials that are dividing each other. It's not suddenly going to be allowed to have this jump discontinuity. How are we doing so far? Are we decent? Okay. So I don't have any doors in here, so I know I can't go through. So it could either be like this or this in general, and of course I have a big giveaway. So y-intercept is there. So if I wanted to, I can kind of, maybe I could put in -1 because I have a feeling it might kind of bottom out like that. So we can put in -1. What do you get when you plug a -1 in? Let's see, twice -3 over 1 times -2. You get 3. So maybe it doesn't. All right, so now it goes like this. You can do it, Jeff. Maybe it does something like that. Now why can't it go through and do something like this? Because again, where would it go then? It's painting itself into a corner. It's got to do that turnaround. Yes, ma'am.
How is it that the different sections, they never touch? It's just like,
You mean like this?
yeah.
These different sections?
Yeah.
Because they're on other sides of this wall, right? And all you can do on a side of a wall is come up against it like that.
Like, that's because
So they can never connect through there.
because of the fracture. Because,
Because it's coming from the domain. X cannot be that. There can be no output here because there can't even be that input there. Does that make sense? That's why the vertical asymptotes are not just suggestions, they are you cannot be here. You can get close to me with that, but you got to slam up against me. You can't be right here. So over here, I've got this guy. So I know it's going to go, it's probably going to go through. And to tell you honestly, if I really wanted to do this to you, and if I do this on a test, I'll kind of spell it out for you a little bit, but I can see if it's going to touch or go through here. Because where did 2 come from? Here. It's a first degree piece, right? It's an odd power, so what do odd powers do? They go through. If it was a squared there, it would touch and turn around. So what I don't know is, does it start here and go through there? Or does it start here and go through there? I don't know. And what is really freaky is, this is still an asymptote here. So what's it really got to do at some point? If it goes through like this, it can't just keep going forever. It's got to at some point turn around and get close to that. Oh yeah. Now, the reason that we can't make this as good as we might want to or something, in calculus, we're going to know exactly where that turning point is. We can find that very, very easily using calculus. Here, we have no freaking idea how to find where the turning point is. So the best I can do is just start plugging stuff in. So what's f of 4, for example? See where it is at 4. What's f of 4? You get twice 2 over 6 times 3. So you get 4/18, 2 ninths. 0.2. So at 4, it's about right there. So can somebody tell me, what does it mean? Where's it over here? Is it up here or down there? You actually should know now. It's got to be down here, so it goes up, through, and then comes back down and starts approaching it. Do you guys see that? I don't really know where the turnaround point is. I could figure out a little bit better, but this is plenty good enough for us. If you plug in f of 3, you can see like where that is. But we really just need to get a semi-rough sketch with some plugging of points to help solidify it. How are we doing?
I graphed it on here.
Yes?
And it wasn't fit the other way, so the parabola was going upside down. It's not pointing
Neat.
negative.
Okay. Yeah. Oh, past the 2? It has no other door. It has no other intercept. 2 is the only place that it can go from down below. So it can never go down. Yeah. Why can't it? Guys. Very good question. Why can't it go through the horizontal asymptote? Again, the horizontal asymptote is based on what idea? Letting what happen? Letting x get really big, right? So when x is relatively small, anything below 1,000,000 is relatively small. Actually, it could be anything else. So big just means crazy big. When it gets really big, then they have to start approaching that asymptote. In the middle, it can do whatever the hell it wants to. So it's not really a wall. It's an eventual suggestion. When x gets big, you better start approaching it. Okay, cool. Anybody else graph this thing? Does it look roughly?
Looks like that.
Okay.
See how you graphed it? You put it in.
Yeah, just put it in.
I like this.
Sorry, thank you.
How'd you do it? I put it in there.
Oh, I put in the factor first.
All right, let's do
You have
this.
to put in like 4 different parentheses to hold
You'd
it.
have to,
Yeah, I know,
yeah.
I did.
It's really easy to get lost in the parentheses if you have too many little pieces. All right, guys, so what I want you to do for a little while is to work on a little handout. It's got another problem that's roughly like this. And then we're going to do a little bit more after that. So, okay.
You and you're feeling better. Yeah.
I wish I felt better. It came back like stronger, man.
Yeah.
It's really good. I suggest you try.
How did you do it?
No, feeling better, I think.
I'd feel better if you said class is over.
Yeah, if you said everything's one worksheet and then call me if you have issues.
I have that power at my fingertips.
If the test was
And I'm not going to use it.
drink a couple beers before the time the class ended, I'd feel way better.
That'd be great. We should start a school.
Yeah, it's called the Marine Corps.
It's called real school.
When I went with my girlfriend, we were going to see her graduated.
Yeah, we got a bar on